Flack math!
Oh yeah, it's time to graph radical functions. That's our objective for today. Lesson 75, graphing radical functions. So, let's go. So in the past, we've had functions like this, like y equals x squared. So if I did a little xy chart here, pick some x's, 0 times itself equals 0, 1 times itself equals 1, 2 times itself equals 4, 3 times itself equals 9. Well, also, the negated versions of those also equal the same thing. So negative 1 times itself equals 1, negative 2 times itself equals 4, negative 3 times itself equals 9. So if you go over here and plot your points, you get 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4. So this is what, if you guys remember, this is what y equals x squared looks like. Okay? So if you guys remember, this is what y equals x squared looks like. So 1, 1, 2, 4, 3, 9, 4, all the way up to 16. So it makes this shape, which is called a parabola. Okay, so now we're gonna go the opposite direction. Instead of squaring something, we're gonna square root something. So let's start with example 1. So example 1 says graph the square root functions and its inverse. Determine the domain and range of both functions. So here's what our function looks like. Y equals the square root of x minus 1. Okay. So when we're graphing radical functions, we always have to keep in mind that there are numbers that will break this function, that will break this machine. So if you end up with a negative number underneath that radical, it no longer is a real solution. It becomes an imaginary solution. So, what's our domain and range? Well, let's see what will break this function. What will turn this radical into a negative number? Well, let's pick some x's and y's and start that way. So let's do our t-chart here. So if x equals 0, y equals, well, let's plug in 0. 0 minus 1 is negative 1. Square root of negative 1 breaks it. So unfortunately, 0 doesn't work. Well, let's try 1. Well, 1 minus 1 is 0. Square root of 1, or square root of 0 is 0. 2 minus 1 is 1. Square root of 1 is 1. 3 isn't very, well, it doesn't break it, but it's not very radical friendly. Because if you plug in 3 for x, you get 2. Square root of 2 is not very graphable. It's radical friendly. It's not graphable friendly. That's a word. Okay, so let's go up to 5. If x is 5, that makes this 5 minus 1, which is 4. Square root of 4 is 2. So what's our next x? Yeah, 10. That's friendly. 10 minus 1 is 9. Square root of 9 is 3. Okay, so if I were to plot these points here, this is what it would look like. 1, 0, right there. 2, 1, right there. 5, 2, right there. 10, 1. All right, 1, 6, 7, 8, 9, 10. Not 10, 3. 10, 1, 10, 3, 10, 3, 10, 3. Okay, so if I connect these dots, it looks like that. So it kind of looks like this bottle rocket gone haywire, and it kind of goes off here. Okay, so let's see how the pros do it. I'm gonna go y equals, now here's something, if you remember, oh, there is a radical sign on this little keyboard here, so let me do that. Square root of x minus 1. So that's what she looks like right there. See the bottle rocket gone haywire? Okay, all right. So this is written in radical version. We call that radical version. We can also write this function in fractional exponent version because you can write every radical as a fractional exponent. So this is just x minus 1 to the 1/2. Remember, in a fractional exponent, the top number is the power and the bottom number is the root. So there's no power, so to the power of 1, and this is the square root or the second root. So these are the same functions, so this is how they would look. Okay, so on a graphing calculator or your nice fancy calculator, if you're not finding a radical, you can write it like this as well. Okay, so it also says, graph the square root function and its inverse. Determine the domain and range of both functions. So let's find the domain. So the domain is anything that will not break the machine, okay? So we found out that 0 will break the machine. 0 minus 1 is a -1, and that will break the machine because we're not going to take the square root of a negative number. That won't give us a real solution. So 1 worked, and it got to 0. But if it was anything less than 1 in there, then it would have gone below 0. So our domain is x has to be greater than or equal to 1, okay? So the range is basically what our result is. This is what comes out of the machine. This is what you can put in, the domain is what you can put in the machine. The domain is, and the range is what comes out of the machine, okay? So if you look over here, this is the result. So it looks like the range, so the up or down values is the range, your y values. So what does it look like? Well, the lowest it goes is right on that x-axis, so y equals 0, but then it goes up to infinity. So this doesn't, it gets slower, but it eventually goes up to infinity. So we're gonna say the domain is y is greater than or equal to 0. Does that make sense? Does that make sense? Does that make sense? Okay. All right. So the other part of the directions is to say find its inverse. So remember, to find the inverse, we just swap the x and y value and then solve for y. So for example, instead of x or y equals square root of x minus 1, we're going to say x. So this is the inverse. X equals the square root of y minus 1. So now we have to solve for y. So how do we get y by itself? Well, first of all, we have to break it out of this cage. So how do you get rid of a radical? Well, we do the opposite. So we're going to square both sides. X squared equals y minus 1. Now the easy thing now is to get rid of that 1. So add 1 to both sides. So y equals x squared plus 1. So far, so good? Is that right? Okay. So remember, when we graphed, this almost looks like the graph that we did before, y equals x squared, okay? But this has a transformation in there. So what we like to do is we'd call this guy our y equals x squared, our parent function, or it's more fun to say mother function. Is that too far? So this time we see a shift. So when you have an exponent or the x is being squared and then you add a constant, that is called a vertical shift. So we're basically taking this mother function, we're going to shift it up 1. So we are going to take this function and we're going to shift that mother function. That's too far. Is that too far? I think that's too far. So let's graph that. Y equals x squared plus 1. So see how that green function, that y equals x squared, just shifted up 1 unit, okay? Okay, so when you're finding the domain and range of an inverse function, all you're doing is swapping the domain with the range, just like when you swap the x with the y. So since the range of the original function is y is greater than or equal to 0, the domain of this inverse function is going to be x is greater than or equal to 0. And since the domain of the original function is x is greater than or equal to 1, the range is going to be y is greater than or equal to 1. So if I graph this, this is what it's going to look like. Boom, 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 boom. So you can see that this is kind of a weird reflection. It's not so weird because it makes sense because it's reflected over this line right here. Well, what is this line? This is x equals y. So this is the line that swaps x and y. So it makes sense that the function and inverse function are reflected over x equals y. I don't know why this means it's reflected. Maybe. I don't know. Okay, so that's example 1. There is a B part to example 1, so let's move on to B of example 1. So graph the square root function and its inverse. So here's what the square root function looks like. Now, square root function doesn't have to be written as a radical in radical form or the radical version of it. We're going to write it in exponential form or the fractional exponent version. So this is 2x, oops, it's not plus 3, it's minus 3. 2x minus 3 to the 1/2, which is basically the square root of 2x minus 3 plus 4. Okay, so we're going to graph this square root function and its inverse. Okay, so should we just find the inverse first? Let's find the inverse first. So we're gonna put the inverse over here. So the inverse looks like this: x equals parenthesis 2y minus 3 to the 1/2 plus 4. All we did was swap the x and y. Okay. So let's solve for y. So we're going to get rid of this 4 over here. Get rid of that guy first. So now we have x minus 4 equals 2y minus 3 all to the 1/2. Okay? So we can, if it helps, you can rewrite this in radical form. You don't have to be fancy, but we're basically trying to get rid of this 1/2 exponent. So how do you get rid of a 1/2 exponent? You apply a 2 exponent. So you're going to square both sides, just like you did in the last one. So x minus 4, we have to square this whole side, so you need parentheses, equals 2y minus 3. It cancels, and you're just left with 2y minus 3. Okay, so now that we have this, I'm going to wait. Like, I know you guys really want to FOIL this out and do that, but we're not going to do that. So let's leave it alone, and I'll explain why a little bit later, maybe this lesson if you're lucky. So we're just going to add 3 to both sides. So then we're left with x minus 4 squared plus 3 equals 2y. Now, to get rid of the 2, by dividing everything by 2. So y equals x minus 4 squared plus 3 all over 2. Okay, so let's create some xy tables here. Okay, so when x equals, let's see, 1.5 or 1.5, that's going to make this into a 3. 3 minus 3 is 0. Square root of 0 is 0. Plus 4 is 4. Okay, so you have to be strategic on what x's you pick. So what will allow you to safely and neatly take the square root of whatever you have in there? So I can take the square root of 1. So what will give me a 1 is if this was a 4 minus 3, I'd have a 1 there. So what makes this a 4? X is 2. Will give you a 4 minus 3, which is 1. Square root of 1 is 1. Plus 4 is 5. All right, what's the next perfect square? It's 4. So what will make this a 4? So how do you get a 4? Well, if this was a 7, 7 minus 3 is 4. So how do you make that a 7? Well, x needs to be half a 7, which is 3.5. So let's pick 3.5 2 times 3.5 is 7, minus 3 is 4, square root of 4 is 2, plus 4 is 6. All right, let's make this a 9, since that's our next perfect square. 12 minus 3 is 9, so how do you make that a 12? X needs to be a 6. So when x is 6, that makes it 12 minus 3 is 9, square root of 9 is 3, plus 4 is 7. Okay, so let's do an xy table for our inverse function. Okay, well, just for the fun of it, let's just swap these and see if it works. Let's see if 4 will give us 1.5. Okay, so let's come down here. We plug in 4 for x, that is 0, squared is 0, plus 3 divided by 2 is 1.5. That works. Okay, let's do our next one, 5. 5 minus 4 is 1, squared is 1, plus 3 is 4, divided by 2 is 2. So I think this works. So here's the cool thing, you don't have to refigure out this stuff. I mean, you can if you want. You know, you're probably bored in your houses today. 7, let's just check this to make sure. 7 minus 4 is 3, 3 squared is 9, plus 3 is 12, divided by 2 is 6. So that works, okay? So let's see what happens when we graph these guys. So we're gonna go over to our graphing calculator. I think we'll just get rid of these guys for now. Actually, we can leave them. So let's graph our functions. Y equals parenthesis 2x minus 3 parenthesis all to the 1/2 plus 4. So that's what that graph looks like. That little red, pink, I don't know what color that is. Okay. So that's what that graph looks like. Let's put in our inverse function and guess what it's gonna do. So here, let's do this. Let's do a y equals x line. So see our line there, our purple line? So according to what we've learned so far, our inverse function should reflect over there. So let's see if it does. Y equals parenthesis x minus 4 parenthesis squared plus 3. I should have had another parenthesis. So I'm going to come back here, put another parenthesis, because if you say divided by 2, after that 3, it's just going to divide that 3 by 2. So divided by 2. Okay, so it kind of looks right, except look at this guy. See how you can see that other part of that? Well, if you just cut it off right there, then that is an actual reflection of this line. Because we do have to consider our domain and range. So let's figure out our domain and range. So is there anything that'll break this? Well, yeah, something will break it. So 1.5 gives us a 3, and 3 minus 3 is 0. So if it was anything below 1.5, then it would have broken this function, because you can't take the square root or you can't apply the 1/2 exponent to any negative numbers, okay? So x has to be greater than or equal to 1.5, okay? And then our range, well, what's our result of our range? Let's look back at our graph. So our range is this red line, remember? So what are the y values of that red line? Well, it looks like it starts right at 4, okay? So y is going to be greater than or equal to 4. So that's our range. Y is greater than or equal to 4. Okay, so if this is our domain and range of our original function, we're going to just reverse that for our inverse function. So if the range of our original function was y is greater than or equal to 4, so our domain is going to be x is greater than or equal to 4. And our range is going to be y is greater than or equal to 1.5. Okay, example 2. The cube root function. All right, So let's just start with an example. Y equals not the square root, but the cubed root of x plus 1. So let's see what this looks like. So let's get some xy values. So x, if x is 0, that's our favorite. Plug it in, you get 1. Cubed root of 1 is 1, because 1 times itself 3 times is 1. Okay, let's try 1. Cubed root of 2 you can't do. What are some other cubes? What are some cubable numbers? Cube rootable numbers. So the next cube on top of 1 would be 8. So if x is 7, then that would be cube root of 8, which is 2. That's nice. What's the next one? Okay, well, let's see. 2 times 2, 3 times 3. 27. 27. So how do you make this a 27? This is a 26. And then you get the cubed root of 27, which is 3. Okay? So if I were to graph that, here's what it would look like. Y equals, I don't see a cubed root, so we're going to do this function. We're going to say parentheses, x plus 1, other parenthesis, and then we're going to do this guy, and we're going to say 1/3. Okay? So this is what our cubed root function looks like. So it's kind of a cool little logo here. Okay, that's what it looks like. So I'm guessing that our inverse function is going to be reflected across that. So let's see if that works. So let's find our inverse function first. So our inverse function is x equals the cubed root of y plus 1. Okay, so we have to get that y out of there. How do you bust out of that cage? You cube both sides. So now x cubed equals y plus 1. So y, get rid of 1 on both sides, equals x cubed minus 1. So let's see what that graph looks like. So y equals x, exponent thingy, cubed minus 1. Look at that. Isn't that pretty? That's cool. Okay. So that worked. All right, let's try a more advanced one. This is B, example 2B. Example 2B. All right, here's our function. Y equals the cubed root, or fancy exponent version. So all this to the 1/3 minus 4. Okay. So if I could do my XY values and stuff, or I could just use a graphing calculator. You don't have a graphing calculator, but you have the internet. So you can use the internet, and I'll give you some, you could just search graphing calculator, but I'll probably leave some links in this video. Okay, so we're gonna graph that. Here we go. So we're gonna say goodbye to our fun, beautiful functions there. They were nice. So this is what we're graphing. So y equals parenthesis 2x plus 3 parenthesis all to the 1/3 minus 4. Minus 4. All right, so this is what that guy looks like. So I'm guessing the inverse is going to be on the other side of that. So let's try just flipping it, okay? So let's do our inverse. Inverse is going to be x equals parenthesis 2y plus 3 all to the 1/3 minus 4. Okay, so we're going to get y by itself. So let's get rid of this extra cargo here, add 4 to both sides. So we have x plus 4 equals the cubed root of 2y plus 3. Okay, get rid of that cubed root by applying a 3 exponent. So we're going to cube both sides. So this is x plus 4 cubed equals 2y plus 3. Get rid of that 3. So remember, we're not going to cube it out. We're just going to leave it like this. X plus 4 cubed minus 3 equals 2y. And then get rid of that 2 by dividing both sides by 2. So y equals x plus 4 cubed minus 3 all over 2. All right. I don't know why I circled it. I like circling answers. Okay, so let's graph that. So y equals parenthesis, another parenthesis, because we're going to have to divide everything by 2, x plus 4 parenthesis all to the third, and then minus, not 4, 3. Okay, and then we're going to divide everything by 2. And look at that! It's so pretty! Yay! All right, so that was fun and exciting. Yeah, let's do example 3. They say the directions say graph the radical function using the graphing calculator, determine the domain and range. So if you guys want to try that, go to the link below and try to graph this and see if you get the same thing I do. So press pause, go to the link, and graph it. All right, I'll wait right here. Press pause. All right, so this is what I got. So I'm gonna just type it out here. Y equals, so remember f of x can always be substituted for y, especially when you're graphing it. So y equals square root of, I'm just gonna do a parenthesis, x plus 1, so square root, so 1/2 plus cubed root of x plus 2. That's what it is. Okay, so that little orange guy. So if that's what you got, you're doing great. Good job. Not sure we'll have these on the test, but it's just fun to do anyway because it does all the work for you. Yay. All right, that's it. There's another application architecture, but I try to stay away from math that you can apply to your real life. So we're gonna skip that one. If you wanna do that, that's great. But I like my safe math that I'll never use in life unless I pursue teaching, which I did that. So, okay. So that is it for lesson 75. Congratulations, you made it. I'm so excited to move on to lesson 76. So tune in next time as we discover, how to find polynomial roots. It's gonna be awesome. Okay, bye-bye now.
Flack math! Give me some math and I'll give you some flack. Flack math!